So we left off with the discussion of the 4 routes of exposure: ingestion, breathing it in, skin and eye contact, and then finally trauma. And we said that the exposure, me being worried about the exposure, is based on 3 separate things: the dose or the concentration, how long I was exposed to it, and the path. So which one of these did I use to expose myself with for the chemical? All right, so one of the things that I want to basically tell you, and I think this is pretty much common sense, is that I can have a hazardous substance on a table, right? And you can walk in, I'm not an artist, you can walk into that laboratory and that hazardous substance is going to be on the countertop. If that hazardous substance has a lid, whether it's a solid, a liquid, or a gas, your exposure to that substance is probably null. Nothing. Nada. So you can walk in and feel safe in that laboratory. A chemical must find its way onto you. And that was the exposure types. Is it getting on my skin? Am I breathing it in? Am I eating it? Those are the types of things that we're talking about. So a hazardous chemical is only hazardous if you have some type of exposure. So the route of exposure is going to be very important. That is the only way that something like this could happen to you. So we're going to break down these routes, and the very first one that I'm going to talk about is going to be ingestion. Eat, drink, be merry. Ingestion is really oral, okay? Through the mouth. You have to swallow it. You have to drink it. It has to come in contact with your mouth, with your tongue, with your throat, with your stomach, and maybe eventually to your large and small intestine. To be toxic with ingestion, it has to be absorbed. And it has to be absorbed by one of these pieces of your body. So the one that we place the most focus on is, of course, going to be the stomach and the small and large intestine. INTEST. Something can actually go into your stomach, into your small or large intestine, and you'll be okay as long as it doesn't absorb. That's the key word here, right? We can actually eat stuff, and it will never absorb through our body, and it will come out our other end. That's not necessarily toxic. There's no effects that come from a chemical that's not getting absorbed by these pieces and parts. So if you're telling me that the only way with ingestion for me to expose myself is that I have to eat it or I have to drink it, and it has to be absorbed, that's the key word, in your stomach or small and large intestine most of the time. There's other pieces and parts that we can talk about, but those are the major ones. If it does not get absorbed, I do not have exposure. So we need to prevent this absorption, which means that we need to prevent the route of eating or drinking in a laboratory. And that is why we have the safety rule that we do. I can virtually eliminate all possibilities of this happening if I do a couple of things. Number one, I never eat or drink in the lab. You're going to see that not only with us, but you're also going to see it with an employer as well. You will never be able to have food or some type of drink in the laboratory. You can have that outside of the laboratory. You can have that in your cubicle. You can have that in your office, but you cannot have it in the lab while you're working. And number two, I don't think that I have to mention it, but I never take anything for granted. I'm never going to taste a chemical in the laboratory. I know, again, you're probably snickering. That doesn't make any sense. Why do I even have to say that? And that's because some people do not have any common sense, and I have to. Never taste a chemical. Never put a chemical in your mouth, okay? As long as you do these two things, you are almost virtually eliminating your route of exposure through ingestion. Never taste a chemical. This was more or less back in the olden days with mouth pipetting. Instead of a rubber bulb on top of a pipette to suck the liquid up into the piece of glassware, they would often use their mouth because it's more convenient and they have more control. So they would put their mouth on top of the pipette. They would suck up the chemical into the pipette like a straw. And sometimes by accident, they would get that chemical in their mouth. That would be exposure. With this said, though, I do want to mention that there is an indirect route. An indirect exposure route means that you did not deliberately do this. This was almost like an accident in a way. Of course, there's no accidents in the lab, right? We shouldn't be using the word accident. But let's say that you put a pen on a counter that you thought was clean. You assume that someone did their job and wiped up the chemicals off the laboratory bench. And then let's say that after you use that pen and you write something with it, you put the pen in your mouth. What you've done is that you have put that chemical in your mouth as well. You might not be able to see it. You probably didn't smell it. It probably didn't have a color to it, or you would have automatically picked up on it. But this invisible, in a way, chemical that was on the lab bench has made its way onto the pen. You had no clue about it, and then you put that into your mouth. You have now incorporated ingestion as the route of exposure. Well, let's say that you didn't put the pen in your mouth, but let's say that you put a finger in your mouth after you handled the pen. That chemical is now on your hands. It's on your fingers. If you get that near your mouth and your lips and you bite a fingernail, hopefully you still don't suck on your thumb, but that would incorporate the route of ingestion into the mix. So now you kind of understand the rule that we have in the lab about food, about drink. We don't want this route of exposure in the laboratory, and we want to eliminate it. We want you to stay safe, and this is one of the reasons that we do it. All right, let's talk about your eyeballs, your eyes. Your eyes can be exposed to chemicals. There's an exposure route. But not only chemicals, but projectiles as well. So this would be something like heating a piece of glassware. Maybe something happens and a piece of glass goes crashing or cracking or breaking, and a small chip gets sent across the room. Maybe you're working across from this person and your eyeball's going to get it. So whatever we do here with our eyes, chemicals and projectiles, you look out for yourself, right? We always say put yourself first, but you also have to look out for others. Again, this is a common theme that we keep talking about. If you're on the road and you're driving, you need to pay attention to the other drivers as much as you pay attention to yourself. The same thing's going to happen here. So one of the ways that we prevent this exposure is through, and you got it, goggles. Wear goggles. That's going to help take care of your eyeballs. If something does splash, the goggles are going to prevent the majority of that from getting into your eyes. If something does crack, whether on you or someone else, and a small piece of glass or a splash drops of chemicals come from someone else across the room or across the way or beside of you, then your goggles are going to prevent your eyes. This is going to prevent that route of exposure. So it's not enough to only wear it when you think you need it, but you wear goggles always. Sometimes you're going to see us let this slide, and we shouldn't, right? But in the entry-level laboratories, if we know that you're working with pennies and water, we're probably going to let you slide by not using or wearing the goggles on that day. At least we're not going to force you to wear them or kick you out of the lab because you don't have them on. Now, keep in mind that chemicals can stay behind. Chemicals can stay on your lab bench from previous classes or previous students or previous employees. And that's the reason that we should always wear the goggles, because even though you're working with safe stuff that you might be working with in your kitchen or at your home, or things that you can find in the grocery store or at Lowe's or Home Depot, all of those chemicals pretty much safe, right? You're probably not going to wear goggles with them at the house, so you're probably not going to want to wear goggles with them in the laboratory. But the reason that we say always is sometimes it's not that what we're focused on. What we are focused on are all of what I'm going to call the leftovers. What was there before you came in? What was on the bench that maybe didn't get wiped up? What was a previous student doing in your area, or a previous employee was doing in your area before you decided to come in and take over their shift? That is why we say always wear your goggles in a laboratory. We want you to be safe. We want to prevent that route of exposure. And this is one of the ways that we can prevent that route of exposure from happening. If you do wear goggles, and you always have your goggles on, I want you to keep in mind that this doesn't necessarily prevent everything from happening to you. You can have goggles on and you can still get things in your eyes. They can come from the top, it can come from the bottom, it can come from the sides. Now, sure, there's different versions of safety goggles or glasses that are out there, but there's always a chance that something still is going to happen. So just because you put on your goggles doesn't mean that you're completely safe. And I want you to keep that in mind. Okay? All right, so that's where I'm going to stop this video. In the next one, we're going to pick up from here, and we're going to talk about inhalation. We're going to talk about breathing stuff in and maybe how to prevent that route of exposure from happening.